Hello, welcome back. So I hope you are enjoying the series so far. Before we add any more features into our little application, we need to do a little bit of refactoring and also make sure that there is some memory leaks in the application. So since we are writing in C, we also need to make sure that whichever memory we allocate inside our methods are freed correctly, otherwise we will have memory leaks. So in this video we are going to focus on finding the memory leaks and fixing them, and also refactoring some of the methods to make it a bit more clean and readable. Okay, so before that I have done something before. So I have prepared this flake.nix file. It is out of the scope of this video to explain how Nix works, how Flake works, etc. But in short, what this does is to give access to a dev shell where we have all these packages pre-installed. So if you want to run this in your system, you don't have to figure out which version of C to use, which version of curl to use, etc. So if you have Nix installed by using the command Nix Develop, you can get this whole environment set up where all the packages are pre-installed and ready to use. Okay, so I have done this already. I'm not gonna explain everything in detail, just to mention one thing. So this is the definition of the dev shell. So essentially when we do Nix Develop in the terminal, it's going to create a subshell with all these packages installed, and then it executes Z shell because by default it uses bash, and this will switch to C shell. So in terms of packages, I've decided to switch to CLang instead of GCC because it's more modern and have more features, so it's gonna be useful in the long run. And then of course for the make file we need GNU make, and for testing in addition to curl I've also added HTTP, which will be more useful to make a post requests, etc. And then C shell for the shell. And another tool we are going to look at today is Valgrind. This will be used to detect memory leaks in the application, so it's gonna be useful for us. Okay, so only thing is I just have to prepare this Nix file, and then here I can do git add. So this will basically tell git that I'm adding this file, and just keep track of it, because when I do Nix Develop it needs the file in the to be tracked by git. So if we have Nix installed, just from this single command it's going to fetch all the dependencies and everything and give us the Nix shell. Okay, take a few seconds to download and get everything ready. So it only takes this much time in the first run. Next time everything will be cached and it's going to be almost instant. Nothing to worry there. So this will also create a flag.log file which is going to have the hashes of the package repositories, so to ensure that we are using the exact same version of what I have using here. Perfect. So let's see. So we should have CLang here. Okay, perfect. So what else do we have to do? Let's modify our makefile to use CLang instead of GCC. So since we are using variables to here, it's pretty easy. So here I just switch from GCC to CLang, and we don't need this anymore. And we can also specify some optimization parameters and also PG, so that we can detect memory leaks using Valgrind easier. Okay, I think that's it. Let's try a build. Perfect. It works the same as GCC. No issues. Let's try running it and make sure everything still works. Okay, everything is working perfectly as before. Great. Now that's out of the way, let's make a commit. Okay, so what are we doing? Switch to CLang, use Nix Flake. Okay, now that's out of the way. Let's start doing some cleanup. So we have Valgrind set up now. Let's try to run this in Valgrind and detect the memory leak. So we need to do Valgrind, and I'm gonna add a leak check equals to full. So it's gonna detect the leaks and also give some more information about what's happening in the memory, and then the binary. Okay, web server is listening and Valgrind is running. So Valgrind is going to modify the application and just essentially monitor what's happening in the memory. And let's do a couple of requests so everything is working. See, yes, all good. Let's cancel it. So the process has terminated and Valgrind has reported a few things. So first of all, there is a memory allocated in the web server run, which is not okay. This is talking about when it was killed. It's okay. So heap summary, total heap usage 51. So we allocated 51 times but only freed 7 times. So you can see there's a huge memory leak there, and it's giving some information. There was a malloc in the parse request. It was not freed. Okay, that's good to know. So here's a leak summary. So it definitely lost 240 bytes. So we need to get this number to 0 or near 0. Okay, now that we have some idea of what's happening, let's go through the code and see what we can find. So before that, I would like to refactor some of these method names a bit to make it a bit more clear and follow the standard practice. So since this is inside web server.c, I would like to prefix every method with something which makes more sense. So here for the web server, we have web server underscore create and run. Similarly, we can have for the request, we can have request underscore receive, request underscore parse, etc. So let's do a find and replace. So parse request parse will become parse request will become request parse. Okay, and then receive request data will become request receive data. Receive request data. Okay. Okay, so I hope that is more clear now. Perfect. Now let's go through the code a bit. So in the web server, okay, where do we start? The web server create, we are allocating the web server, but I don't think we need to free this anywhere because there is only one instance of the web server in the entire application, unless there are like multiple servers running in parallel. And this is a long running object which is going to be in the memory forever until you close the application, and of course when you close the application everything is freed. So I don't think we need to worry about this. And in the web server run, what are we doing? So we are binding, listening, no memory allocation here, and then here we get to some interesting part. So we are getting an address of the client. Okay, so these are all inline variables, so should be fine. And we are preparing the buffer here. Okay, which is freed here. We are good there. Okay, and then what else? Okay, I think we are good here. Only thing I would say is that we are preparing the request here. So we need a way to free everything in the request structure. So it's not just the structure but also the things inside it. So I think we need a separate function to destroy this basically. So I would actually create a separate method for it. Let's call it a request destroy. Okay, so this will take request parameter. Okay, so basically this has to be able to completely destroy the request object. Okay, so the reason why we need this, every time we connect from a client, the request object is created, which will contain the headers, body, method, etc. And each time a new client connects, it just discards, or after the request is processed, we need to discard this. Okay, so what do we have? We have the method, path, headers, and body. Okay, let's free everything one by one. Free request body. Okay, that's easy. Request okay, so method. Okay, so we freed method, path, body, and for the headers we'll have to loop through it and free all the header one by one, and then free the pointer to the array itself. Okay, so for title 0, I less than request headers count plus plus request headers. So inside the headers we'll also have to get rid of the key and value. Okay, free everything, and then finally free the headers, and then last but not the least, free the request itself. Okay, I believe that's it. We'll have to make sure that all of them are pointing to something which was allocated correctly. We'll see in a moment. So after freeing the client, freeing the buffer, free the request. Perfect. So next thing is we had to go through the request parse. So what can we improve here? I think we kind of did all this code in a hurry and it's not really in a perfect shape. So let's try to improve the situation a bit. So first of all, I would rename this rest into something which is more meaningful. So as per the recommendation of strtok, this is a save pointer which is going to save the current state. So let's call it that. So rest should be save ptr. So okay, that makes it more clear. And what else? So okay, so we need to have reference to the copy of the buffer. So let's keep that separate, and the save pointer can just be like that. So we have a copy here, and we are going to use this in the strtok function. So the strtok function will modify the original array. So since we have a copy, it should be fine. So it's going to modify this array and it's going to save the state here. So we don't have to initialize this and let the strtok method take care of it. Okay, so here in the strtok method, it's going to take actually it can take the copy, so first parameter, and then save the state in the save ptr. Okay, so and also when we get the token, this token is going to be pointing to the modified array in copy. So essentially what this method does is it finds the position of this delimiter, puts a /0 in that position, and returns the pointer to the beginning of the array. So basically this modifies the copy buffer, So since we are going to be freeing this copy buffer at the end, let's make a copy of that here so that we have a copy in this variable, and we are anyway free in the method here. So that's good. And on the second term, since the save pointer is going to be pointing to the location after the first occurrence of this, we don't need to pass it again. This should work. And again we are going to do a duplicate. Perfect. So save pointer is going to be okay. This looks good. So we have the first part delimited by space, then the second part by space, and then find the, so each line is going to be ended by /r/n. So we don't care about /r, so just find the location of /n, and we just start from there. So we ignore the HTTP version parameter in the first line. Okay, and the position is going to be the position of the /r/n/r/n, which is the end of the headers. Okay, looking good so far. And then what else do we need? Headers count 0, then loop to the buffer. Oh good, oh good. No memory leak here. Initializing the headers, we are cleaning it up later. Okay, then we initialize the loop here. So this is using the save pointer. Actually we can just leave it as null, because anyway it's using the save pointer. And then as a safeguard, since we have the headers count here, we don't need to, we can have additional safeguard here just to check whether the I is less than the header count. So in case the request is malformed or something, this will be an additional safeguard to avoid an infinite loop here. So that's interesting. So here we are delimiting based on /n, but actually it should be a /r/n. So that would explain some weird formatting in the printf while I was debugging. So it's good that we found it. Perfect. What else? This looks good. So right after the first /r, we might not even need this, since this will be broke here, but let's keep it there and remove it after some testing. So we do initialize the head, initialize the key. Actually we can do it in a better way. I think strtok is a bit more complicated here, so let's do it using strchr. So let's try to find the position of the colon. It's a single character anyway. strchr token. Oh, come on. So this will give us the position of the colon in the token. So this is the line of a header, if you remember. Now that we have it, so we can specify that the key will be we need to duplicate the token for sure. So let's do, so this is the position of the colon, so we need from the beginning of the token string until the start of this. So we need to make a copy of the string token until position minus token. So this will be the length of the string until this. Okay, and similarly, so for the value, just okay, for the value that should work. So copy of the token starting from the position +2, because we don't care about this and this. Okay, so there is a space right after it basically, so we skip those two and get to the next word. That means we don't need these two complicated parts and then assign it to headers. Okay, now for the body, so if you remember, the position points to the beginning of the body or end of headers. So if we take the position and add the size of this, we will get the beginning of the body. So as always, let's do a duplicate of the memory, position +4. Okay, then we can free the copy and return. Okay, let's give it a try. Make run http or else to curl. Okay, looking good. http post and okay, that's interesting. So we have the method, path, headers, host, accept encoding, everything, blah 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 blah. So the headers are looking good, but for some reason the body is not here yet. Did I forget to save for some reason? Ha, I did. Okay, perfect. So I think it's pretty clean now. It's not perfect, there are a million better ways to do it and 1,000 ways to optimize it, I'm sure. I don't claim to be an expert in C or anything, but so far it looks good. And let's try Valgrind. Okay, so we still have some memory lost, but I think it looks much better now. bytes in 8 blocks are definitely lost. Okay, in str_dup. Okay, so in the request parse we did some str_dup and forgot to free. What is that? Let's look at this again. So headers, body, method, path, request. Okay, inside headers, key value. We forgot to free the headers object itself. Okay, position +4, free the copy. Okay, and here we are freeing the buffer. What else did we forget? Aha, we forgot to call the free destroy request. Okay, oh wait, it's request destroy, isn't it? Okay, now what? Oh, look at that, definitely lost is 0. Perfect. So we made 112 allocation, 112 freeze, so the remaining 2 are from the web server, so that's totally fine. Perfect, I think it looks really great now. Let's do a git diff. We have changed the method name, some renaming here, same here, and this method is much more improved and more stable and rigid now, and we are taking care of the memory leak. Perfect. I think that's it for this video. I will commit everything, and as always it will be available in Git. So continue following along. In the next video we'll add the methods to get request parameters, and we will also have to start looking into allowing the main methods to act on the request and provide responses back to the client. So we have to now start slowly developing our APIs, and gradually we need to get to the stage where we have some HTML content, and in the UI users can interact with it and the servers can respond with it. Another thing I wanted to show you is if you do the size of the web server, it's only 20 kilobytes. So I'm sure if we complete this application it will be less than 50 kilobytes. So imagine having a whole web server under 50 KB. It's just awesome. As always, I don't recommend running this in production or anything like that. So this is just for learning and fun. Thank you.